Hello students, welcome to our today lecture. In our today lecture, we are going to apply the VAR model. Basically, VAR model is used when there is no difference between dependent and independent variable. In your model, your all variables are independent. So VAR mean vector autoregressive model. Auto mean there will be the lags of your dependent variable in your model as an independent variable. So that is called autoregressive. Autoregressive means that your dependent variable lag is present as independent variable in your model. So now let's start that how can we apply VAR model. First of all, we have to select the data, as I have three variables: import, saving and GDP, and my data set starts from 1976 to 2020. So I will select all my data from here and I will open the eViews, and then I will open here new work file. Then I will paste the start and end date of the data. My data start date is 1976 and the end date of data is 2020. So, and my data is annual based, so I am going with the default option. If you have data in different forms like semi-annual, quarterly or monthly, you can choose the option according to the base of your data. So as my data is on annual basis, so I am going with this option, annual. And in this option you have to select that whether your data is unstructured, dated or balanced panel. My data is time series, not panel, so I am going with the dated regular. Dated mean that my data has start and end date as well. Undated mean that your data have no start and end date. So I am going with this option that my data has start and end date. So after applying all these options, I will click on OK. Then I will go to quick empty group and I will paste my all data set here. As you can see that my all data is now present in the eViews work file. After that, I will select all my variables like GDP, import, saving. Then I will click right button of the mouse and open as group. Then I will go to quick. Here at the end you can see the option of estimate VAR. Then I will click on estimate VAR. Here it is asking me that insert your endogenous and exogenous variable. Endogenous mean that dependent variable. So we are assuming that all our variables are endogenous, as in VAR model there is no difference between dependent and independent variable. So we are assuming that all our variables are independent. So I will type all my variables here: GDP, import and saving. And here you can see that it is asking standard VAR, vector error correction or Bayesian. In this lecture we are only interested in standard VAR. In our coming lectures we will discuss about vector error correction and Bayesian VAR as well. But at the current moment we are only interested with the standard VAR. As you can see that we have three variables: GDP, import and saving. So we have three equations in our model. In first equation, GDP is dependent variable and import and saving are independent variable. Then in next equation, import will become dependent variable, GDP and saving will become independent variable, and in last equation saving will become dependent variable and GDP and import will become independent variable. So we have three equations in our model. Next, it is asking about the lags, that how much lags you are willing to include in your model. You can change the order of lag by your own choice, but I am going with the default option 1 and 2. So when I click on this, the result window will appear. As you can see that I have told you earlier that we have three equations in our model. So as you can see that this is the first equation of the model, this is the second equation of the model, and this is the third equation of the model. And as we have selected two lags, so as you can see that this is the lag of GDP first year and this is the lag of GDP one more previous year. Similarly for import and saving, it has included two lags and C is constant. So we have total 7 variables or 7 coefficients: GDP, lag 1, lag 2, import lag 1, lag 2, saving lag 1, lag 2, and constant C. So we have 3 models or 3 equations and 7 coefficients. So in sum we have total 21 coefficients, 7 of each model, 7 coefficient of this model, 7 coefficient for this model, and 7 coefficient for this model. This first value is the coefficient value of the GDP lag. It is explaining that how much GDP is correlated with the 1 year previous lag, and this is the coefficient that how much GDP is related with the GDP 2 year previous lag, and this coefficient is explaining that how much GDP is explained by 1 year import lag value. Similarly, this value explains that how much GDP value is explained by the 1 year lag value of the saving. And these are the values of standard error. As you can see that here, this bracket shows the standard error and this bracket shows the values for t statistic. So these are the value of standard error and these are the values of t statistic. So how can we get the t statistic value? By dividing coefficient with the standard error. By dividing this value by this, we will get the value for t statistic. As you see that all our results are here, but we have to tell that whether the results are significant or not, we have to see the p value. But in this result window we have no p value, so we have to find out the p values. So it will be easier for us to explain that whether there is a significant relationship between these variables or not. So what we have to do, we will go to the proc. Here you can see that proc, then go to make system, then select order by variable for seeing the p values. When you click this, it will show you the 3 equations of your model. As I told you earlier that if we have 3 variables, we have 3 equations in our models. If we have 4 variables in our model, then we have 4 equations, and if we have 5 variables in our model, then there will be 5 equations in our model. And each model or equation contains 7 coefficients, so there are 21 overall coefficient present in our model. So after this I will go to estimate, then I will simply click on OK, and now it gives me the probability value or the p values. So now it will be easier for us to explain that whether these results are significant or not. As you can see that C1 coefficient p value is greater than 0.05, which means that it is not significant. Okay, for significance the p value must be less than 0.05. So as you can see that our p value is nearly 1. So it means that this particular variable have no effect on our dependent variable. Similarly, you can see that C4 is also significant, but when you look at the coefficient C5 p value, its p value is less than 0.05. So this coefficient is showing a significant effect in the model, and so on. You can check all other variables significance by looking at their probability value. 0.05 is the benchmark, but in some cases if our value is less than 0.1, then we also say that that particular variable have significant relationship, but there is a weak significant relationship. So you can if your variables are significant and 0.1%, then you can also interpret these results, but the values above than 0.1, it means that now your variables are not significant. So as you can see that equation GDP equation have 7 coefficient from C1 to C7. So C1 to C7 are the coefficient of this first equation from this point to this point, and our 7 equation is of import. So the coefficient from C8 to C14 is the coefficient for second equation, and this C14 is the constant of this particular equation. Similarly, C7 is the constant of this particular equation, and the last equation is saving, and its coefficient start from 15 to 21, and 21 is the constant. So you can see that import, let's say 1 year import lag have any effect on the saving, and its coefficient value is C17. So I will look at C17 and its probability value is greater than 0.05, which means that this value have no impact on the dependent variable in this particular equation. So this is the VAR model and the interpretation of the VAR model. You can also check the joint coefficient, joint significance of the model or joint significance of the variable. So what is the guideline? As you can see that for significance we will see the Wald coefficient test. So if we want to see that C1 and C2 or C3 or C4, you can choose all the numbers by or the coefficient by your own choice, but I am going with C1 and C2, and I want to check that whether C1 and C2 jointly affecting the GDP. So for this I will select that C1 and C2. So what I have to do, I will go to view, then I will go in coefficient diagnostic test, and here you have to select the Wall coefficient test. So here it is asking you that for which coefficients you want to check joint significance. So I will write C1 equals C2 equal 0. So here it will gives you the results for the Wall test, and the null hypothesis is that C1 and C2 equals to 0. It means that they are not affecting your dependent variable jointly. So what is the guideline for accepting or rejecting this null hypothesis? You have to see the p-value of chi-square test. As you can see that its value is greater than 0.05, so you cannot reject the null hypothesis. You have to accept the null hypothesis. Okay? If the p-value is greater than 0.05, you have to accept the null hypothesis, and if it is less than 0.05, then you have to reject the null hypothesis. So as you can see that my probability value is greater than 0.05, so I have to accept the null hypothesis, which means that C1 and C2 equals to 0. So what does mean that C1 equals to C2 equals to 0? It means that they both are 0 and they are not affecting my dependent variable. So if this value is less than 0.05, so in that case I have to reject the null hypothesis, and alternative hypothesis is that they are jointly affecting the dependent variable. So in that case it means that they are not 0, but we have probability value greater than 0.05, so we have to accept the null hypothesis, which means that these two coefficients are not jointly affecting our dependent variable. So this is all for the VAR model. If you have any question, you can ask me.